Good morning, good afternoon, or good evening. Today, we are creating a list of videos under a Senior 3 topic that is called Sequences and Series. We shall handle sequences and series in two phases. The first phase will be sequences, and then in the second phase, we shall look at series, and that would form the end of our topic called sequences and series. A reminder, this is Vision Plus, and if the materials and the resources that we are making on this platform are resourceful, then we encourage you to share with your friends, your colleagues, and even your classmates. So, beginning with sequences, what are sequences? We are saying here that sequences are ordered lists of numbers that follow a specific rule or a specific pattern. That is what a sequence is. It is just a set of ordered lists of numbers that can follow a given pattern or a given rule. Therefore, why is it important for us to study sequences? Studying sequences helps us make predictions in real life, such as sequences can be used in estimating future population. They can also be used in calculating how long it takes to repay a bank loan. It is also important because we are in position to predict when a natural resource will run out, and then we use it in finding the total distance traveled by a bouncing ball. And finally, it is important for us to know sequences because we apply it in determining how long an investment takes to double. These are some of the reasons why it is important for us to study sequences. A reminder, please keep in mind that your examination can never test you to give the reasons for studying sequences. However, I have put them here for you to know that the topic you are about to learn is practically applied in your life. Alright, going ahead, I have already defined what a sequence is, and a quick reminder, we have said a sequence is a set of numbers that are arranged in a particular order. Okay, there is a given order in which a sequence is arranged, or there is a particular manner, a particular rule in which the numbers making up a sequence are arranged. That is the definition. Now let us look at these examples. The first example here is a sequence of odd numbers. It is a sequence of odd numbers, and the sequence is 1, 3, 5, 7, and 9. What do you see about this sequence? This is a sequence of odd numbers. The first number is 1, which is an odd number. The second number is 3, which is an odd number. And the sequence continues. How do we get the following term of a sequence? 1 is the first odd number in this sequence. How do we get 3? We simply get 3 by adding 2 to 1, such that when we say 1 plus 2, it gives us 3. And now for us to get the number after 3, we simply add again 2 to 3. When we add 2 plus 3, we get 5. 5 plus 2, we get 7. 7 plus 2, we get 9. 9 plus 2, we get 11. 11 plus 2, 13. 13 plus 2, 15. And that is how we obtain the odd number sequence. So what is the rule here? The rule is simply we are adding 2 to the previous number. That is an example of a sequence. The second example is a sequence of square numbers. What is a square number? A square number is a number that is obtained by multiplying a natural number or a whole number by itself. For instance, if these are our whole numbers 1, 2, 3, 4, for me to get the square number of 1, I should say 1 times 1, and that gives me 1 that you see here. And again, for me to get the next square number, I come back. 2 times 2 gives me 4. 3 times 3 gives me 9. 4 times 4 gives me 16. And then 5 times 5 will give me 25. And then 6 times 6, I get here 36. 7 times 7, I get 49. 8 times 8, I get 64. And then 9 times 9, I get 81. So this is a sequence of square numbers. Remember, in other words, a square number is a number that has a perfect square root. So for all these numbers here of this sequence, if you take their square roots, you get a whole number for each of these numbers. And therefore, the simple rule in the sequence of square numbers is they are obtained by multiplying a whole number by itself. Okay, now the last example that we have here is an example from a sequence of alternating sequence or alternating numbers. Like in this case, here we have 1, negative 1, 1, negative 1, 1, negative 1. The numbers keep on alternating. Here there are two numbers. And when we say alternating is the same number appears after a given interval. So here 1 and then negative 1, and now the 1 reappears again, and negative 1 again reappears in the next. So that is what we call alternating sequence or alternating numbers. The same number keeps on appearing in a given manner. So those are some of the examples that we can look at under a sequence. These numbers or these examples here are just to boost your understanding, but however, there are very many other rules or patterns that you will see depending on the number. So the key takeaway that you need to keep in your mind is train yourself, get the ability to recognize the changes in the sequence, and then be in position to come up with the rule or the order of changes. Yeah, those are the examples that we can see under sequence, which is a set of numbers that are arranged in a given manner. Now, let us look at what we call infinite and finite sequences. Okay, what is an infinite sequence? An infinite sequence is a sequence that continues forever. The sequence never stops. That is what we mean, and it is indicated by ... So if you find a sequence, for example, 1, 3, 5, 9, 7, 9, and then it continues, this means that it is an infinite sequence. It does not stop. It continues up to infinity. So it continues forever up to infinity. That is what we mean when we say the series or the sequence is infinite. And then what about a finite sequence? A finite sequence is a sequence that has a fixed number of terms. Okay? It has a fixed number of terms. In other words, this is a sequence that stops. This is a sequence that does not continue forever. It starts and stops at a certain point. Unlike the infinite series that continues up to infinity, the finite sequence stops at a given point. For example, 1, 3, 5, and 9, and they stop there. Another example here that we can draw is 1, 2, 3. It continues here, okay? But it stops at a given point, n. It means the numbers here that they have not shown, but definitely our sequence stops at a number n, where n is our last number of the sequence, okay? Our n is the last term of the sequence. And in this example, 9 is the last term of the sequence. Alright, so these are the two sequences that we shall be in position to encounter in our learning. It is either infinite or finite. Infinite continues to infinity or never stops, but finite stops at a given number. Alright.